What are the applications of alternating current circuits? Basically, we consider one of the best applications of this in the form of a transformer. Whenever we consider a transformer, it works only on AC first. That's a very, very important aspect to be remembered. Transformer does not work on DC. It works only on alternating current circuits, that is only on AC. And what is the use of this transformer? In fact, we all can understand straight away. Transformers are mainly used in two ways. Either to step up the electric current, the voltage, or to step down the voltage of electric current. What exactly is stepping up or stepping down? That if you take up, there are two types of transformers. One, of course, we call it as a step up transformer, and one we consider it as step down transformer. The basic principles of that one and important features of that, let us discuss now. Transformer. One is step up transformer, I said. One is step down transformer, I said. What makes the difference between these two? In the case of step up transformer, output voltage will be greater than the input voltage. Whatever the input we are giving, more than that value we can extract from the system. That means voltage is going to be stepped up to few times the original value. Whereas a step down transformer is quite opposite. Whatever input we give, less than that input we people is to get directly in the output. That means the voltage value is going to be reduced so many times than the initial value or given value. This is what is called as a step down transformer. Generally, when we take the basic concept here, transformer of course will be having a soft iron core like this, and there will be a primary coil. There will now be a secondary coil over here. This is what we call it as primary coil, and this one we take it as secondary coil. When we consider primary coil, the number of turns in primary coil, I can write it as N primary. The number of turns present in the secondary coil, I take that one as N secondary. Exactly in the same manner, the input value of voltage, what we are giving here, I call it as E primary. Similarly, E secondary we used to take it. Likewise, the current in the primary coil, I consider that one as I primary, and current across the secondary coil, I take that one as I secondary. Now, usually whenever we consider a transformer, we always prefer to take that transformer to be the ideal most. Ideal transformer we call it. In reality, ideology is only on paper. No transformer that can give 100% efficiency, we know even that point also. But while taking the calculations part of it, we always refer to a transformer as an ideal one. And what is the basic condition for an ideal transformer? The condition is quite simple for us to understand. For an ideal transformer, we can write input power is equal to output power. Whatever the input power we are getting, or power input we call it in short form, and power output we take it over there across the secondary. If both are equal, that kind of a transformer we call it an ideal one, ideal transformer. For all practical calculations, we consider the transformer to be ideal. Then what happens? The power output by power input, we call this one as efficiency. Efficiency by formula we can write it as power output by power input. But for an ideal transformer, since power output and input are equal numerically, efficiency becomes 1. In terms of percentage, suppose if we want, into 100 we write, that time that transformer is going to have cent% efficiency. This is what actually we people is to take it directly. But now, when we write power output by power input into 100 as eta, the basic rule for ideal transformer is that numerator and denominator are supposed to be equal. So what I can write from this one? If power output is equal to power input, then what I can write? E secondary into I secondary must be equal to E primary into I primary. EMF across the secondary terminals or secondary coil into current across the secondary coil. The product of E and I itself we call it as power. That now must be equal to E primary into I primary. What is the other version of the same equation now? E secondary by E primary is equal to I primary by I secondary. E secondary by E primary is equal to I primary by I secondary. Fine. But we can all understand well, more the number of turns, more will be the EMF. Therefore, you can even rewrite the same this way, N secondary by N primary. So, E secondary is proportional to N secondary, E primary is proportional to N primary, E secondary is inversely proportional to I secondary, E primary is inversely proportional to I primary. This is the basic equation one should remember to solve any problem that is asked on a transformer. But in this particular case, how can we identify whether the transformer is a step-up transformer or, for that matter, a step-down transformer? If I consider the number of turns in the secondary is greater than number of turns in the primary. If number of turns in the secondary coil is greater than the number of turns in the primary coil, then we call this one as step-up transformer. Secondary number should be greater than primary number. Then whatever the input we are giving, the output what we are extracting from the transformer will certainly be many a number of times more than the input what has been given in the form of EMF there. So secondary voltage is going to be higher. That's why we call this one as a step-up transformer. When we consider the other way, that is, if number of secondary turns is less than number of turns in primary. That means primary number is more than secondary number. Then of course induction takes place a little less. Due to that, the output voltage, whatever we are going to extract out of that, will surely be less than the value of input that is supplied to it. That is the reason why we call such type of a transformer as a step down transformer. So, step up transformer or step down transformer, that is going to be decided by considering the number of turns in the primary coil and number of turns in the secondary coil as such. If number of turns in secondary is more than number of turns in primary, that is to be called a step up transformer. If number of turns in secondary is less than number of turns in primary, that's what is called step down transformer. So overall, while discussing about the basic principles of transformer, one should understand this equation thoroughly. Almost every problem can be solved by using that. Another important feature I have already mentioned in the beginning itself, this transformer works only on alternating currents. It doesn't function, it does not work on DC. So sometimes he may ask us a question saying that a primary coil in a transformer is connected across a cell of 12 volt. A cell, very clear indication it is a direct current. So the moment that fellow has connected a cell across the primary, no need for us to use any formula there. It does not work for DC at all. Therefore, whatever the answer, what he wants exactly, that will be 0 only. So no need for us to calculate in anything. By looking to that cell connected across the primary or DC is connected across the primary, no need for us to calculate any of the values out of it. So that is the advantage what we have, only it works on alternating currents, not on direct currents as such. Therefore, it works only on AC is the primary concept one should remember as far as a transformer that is concerned.